Well, good afternoon or good evening. We'll get started in just a second here while some people join us from the waiting room. Well, good evening. I think we will get started. My name is Professor Laura Albert. I'm a professor and David H. Gustafson Chair of Industrial and Systems Engineering at UW-Madison. And I'm going to talk to you about bracketology today. And you're welcome to answer or ask questions at any time in the chat, and then I'll answer them at the end. Some of you are familiar with the department, your current students or alumni. If you're not, I just want to briefly mention the department that I'm chair of. It's the Department of Industrial and Systems Engineering at UW-Madison. We are located in the Mechanical Engineering building, and I can see the football stadium and the practice field from my office, which is always an inspiration to my research. And we have degrees, a bachelor's degree, we have several master's degrees, including a research master's and professional master's degree, as well as a PhD degree. And you can check us out online if you're interested in more. I will say that my department is amazing. We are very well known for our research. Our average annual research funding is more than $10 million a year. And we're ranked #1 in the nation among industrial engineering departments for research dollars per faculty and in a faculty scholarly productivity index, academic analytics, which is my favorite ranking since my department's ranked #1 in that ranking. All right, so my overview of the talk is really on the math behind bracketology, and I'll have some practical tips at the end. I'm first going to talk about some of the mathematics behind ranking sports teams. If you're like me and you're not a real expert at football or ranking, you can still produce experts that are indistinguishable from those of, or rankings that are indistinguishable from those of an expert, just using math. And I think that's pretty amazing. I'll also talk about how to forecast the college football playoffs. So how to forecast and predict who might be the best team at the end of a season, even though you're in the middle of the season. And at the end, I'll give some practical bracket tips for filling out a bracket. I want to briefly just mention my research and why my research in industrial engineering has anything to do with bracketology. I'm an industrial and systems engineer, and my lab really studies how to manage risk in public sector systems using optimization and other mathematical models. Some of the applications I study have to do with public safety. So in my research, I've studied how to locate and route ambulances and fire engines to emergency calls for service. And recently, I've also been studying how to do this in police systems, particularly for calls having to do with opioid usage. I've also studied infrastructure protection and resilience applications that span from aviation security policy to election resilience and cybersecurity. So this is a lot of different applications, and they do have a few things in common, which is the methodological base from which I study them. And I want to briefly make the connection from that research to bracketology. And I'm going to do it with this picture of a slinky that represents a system. And a system is a set of things, which can be people or vehicles or computer networks in my research, but also basketball teams or football conferences. And they're interconnected in such a way that they produce their own behavior over time. So I like to say that a single car is just a vehicle. A bunch of cars can be a traffic jam. And a bunch of football teams in the SEC can be a really dominant conference. And my discipline of operations research is the science of making decisions using advanced analytical methods that's really applied at these problems and systems. And other disciplines study systems as well, but maybe they have a slightly different focus. And I have a picture of a slinky here representing the system, because if you move one part of the slinky, the whole slinky moves. You can't really just contain part of the slinky. And those interconnections are really what we're studying in when we study systems. And those interconnections are really relevant when we're interested in answering questions like which team is going to win next week and how do I fill out my bracket? Because there's a lot of interconnections between those teams and the conferences. So to illustrate that, I'll give a couple examples first. Some of the examples of operations research in our connected world can include transportation systems, so railroad schedules, scheduling airlines, also healthcare, so scheduling appointments and surgeries, also kidney exchanges. Service systems spanning things from call centers to Disney theme parks. More recently, the sharing economy, so an interconnected system with also user participation. And in the last couple of years, logistics and last mile delivery, and AKA, how do we get those packages delivered on time? Right, so there's a lot of different applications. And sports leagues are also really interesting in that they are also interconnected. And I have a picture here of a graph of a college football season. This was the 2014 college football season, and it's color coded, so you can see the conferences. You can see that there's structure here. So I'm very interested in the structure. And you can also see, if you are looking for Wisconsin, there's Wisconsin on the graph, right? So how do we use this structure to inform how we might want to rank teams? That'll be kind of the discussion of my talk, and I'll step you through some of the calculations without actually doing too much math. So how did I get involved in all of this? From my research, getting involved in bracketology, and I was a little bit of a late bloomer with bracketology, and I got started with the college football playoff. So about almost a decade ago, the college football playoff was announced, and somebody asked me like, hey, wouldn't it be cool if you could predict who would be in the college football playoff? And I was ready for a challenge, and believe it or not, professors we have to develop our skills and involve ourselves with continual lifelong learning. And I thought sports analytics would be a great opportunity for me to hone my skills and learn a few new things. And so I began Badger Bracketology. Some of what I do in sports analytics includes ranking sports teams. I rank the college football teams, also the Division I men's basketball teams, and the National Football League teams. In addition to that, I use sports analytics in the classroom. So if you ask me a question that's outside of this talk, I might have looked at it and developed a case study. So I've developed some models for sports decision-making, so situational decision-making, win probability models, and other predictive models. One of my favorite examples is the Women's World Cup win probability model using real data. And I also talk about sports analytics in the news, and I'm happy to say that the average fan is a little bit more interested in the mathematics behind what's happening on the court or in the field than they used to. So usually I have some media appearances the week of March Madness, but just over a year ago, I was on a radio program to explain the NFC championship game, the 2021 NFC championship game, and some of the questionable Green Bay Packers decision at the end of the game. And I broke down the mathematics of it, and yes, they could have made some better decisions. I'll leave it at that. But it was really interesting that the average fan actually wanted to know the explanation. And that was such a great opportunity for me, and hopefully the fans too. All right, so I want to move on to the basics of rankings, and I'll talk about other ways to rank teams once I get through a bit of an explanation. But ultimately, we're trying to collect data and use some kind of some statistics or some kind of mathematical model to make a data-driven ranking that maybe has some predictive ability. And the model that I use is based on Markov chains, and I teach them in my classroom. They have many different applications, and ultimately, it's a probability model that's interested in predicting how a system evolves over time. So again, it's that system tie-in. And it's a model that I use in the course that I've taught, Industrial and Systems Engineering 624. And it's a very generic math model in the sense that there's so many potential applications. There's so many systems whose behavior we want to study over time. One of the most common applications includes finance models. Another common application includes epidemiological models. As you've probably seen some charts in early 2020 that were based on Markov chains, predicting how many COVID cases there would be and how many COVID deaths there would be. I still see them in the news. Markov chains are also the basis of queuing theory and used widely in modeling of service systems. All right, which brings us back to our graph here. I have this of the college football, all the college football teams. There's about 3 times as many Division I men's basketball teams, and it's pretty hard to visualize on a slide. But here's the basic idea with a Markov chain. So this is our system that we're studying, and each team is a dot on this graph that represents a state. And with the Markov chain, we move to teams that beat that team that we're in. So you can think about randomly moving to one of those teams that beat the team. And if I keep moving around here from team to team, there's some teams that I probably will almost never visit because they didn't win any games. And then there are teams that win a lot of games. I visit those teams quite frequently. And the teams that win a lot of games against very good opponents are the ones that we visit the most. And if I can measure how frequently we visit a team, then I can use that as some kind of score or rating that I then use to rank the teams. And that's my 30-second explanation of how I use data to rank teams. Some of the weaknesses, one of the weaknesses is I don't want to just look at wins and losses. There's home field advantage plays into this, the strength of the win, so that maybe the score differential is also informative. So I'll show some data having to do with that. And this is why the very best teams, like it's usually Alabama, so the best SEC teams and the best conference usually end up being the highest ranking teams. I'm often asked, is there a formula for strength of schedule? And the answer is no, it's just sort of determined endogenously by the model and the data. If that process sounds familiar, it's because we've interacted with Markov chains for a while through search algorithms on the internet. The original Google PageRank algorithm, which was an algorithm that changed our world, is based on Markov models. So Markov chains are really great. And if you are old enough to remember search engines before Google, you know how important Markov chains are because the search engines were pretty bad. It was really hard to find the sites with the best information because they didn't really percolate to the top. And PageRank is a ranking algorithm. All right, so I wanted to show you some of the data and how I can go from a score to a ranking. And there's this basic 3-step approach to it. First, I collect some data, which in my case just uses simple data like box scores. And then I create this model that does something cool with the data. And then I apply the mathematics and I get the ratings and the rankings at the end. So the first step and the third step are pretty straightforward. It's just the model, that middle step is where all the magic happens. Before I get into an example, I want to explain the rest of the process, which I use for the college football season, which is what if the season's not over yet and I want to know the rankings at the end of the season. In that case, I can repeat this process by simulating the following weeks of games, which gives me new data, which I can feed back into my model for ranking teams until I get to the end of the season. Okay, so let's look at men's college basketball. I have an example from this season. It's between Minnesota and Wisconsin, so our rivals. And a lot of teams in the same conference play each other twice during the season. There's a home game and then there's an away game. And this is an important part of where I get the data for this model. So in this case, in the first game of the season, it was at Wisconsin. Wisconsin won by 6. They won 66-60 over Minnesota. So the question is, how much credit should they get? And the example I gave earlier, there's like full credit. You just move randomly to a team that beat all the teams that beat you. But here I'm going to give partial credit. And so I might think Wisconsin should get a lot of credit for this victory, but I'm going to give a data-driven answer. And what I did is I collected several seasons worth of data. just looking at the games where teams played each other twice during the season. And I look at that score differential in the first game, which was 6 for this example. That's on the x-axis here. And then I looked at the score differential in the next game, which is the y-axis. And so in the first game, the team you're looking at has home court advantage. That's worth a few points. In the next game, it's an away game. So the other team has home field advantage or home court advantage. And you see a bit of a plus sign here because games don't end in a tie. And you also see a bit of a skew that reflects that a team that wins the first game is likely to win the second game, but it's definitely not guaranteed. And there's also a little bit of a skew due to home court advantage. So you see up in this upper right quadrant, these are all the scores where the team won at home and then they won again when it was an away game. And then you see in the bottom right quadrant, the team that won at home loses their next game. So one of those two scenarios is going to happen for Wisconsin because they won their first game at home. And the relevant data is this skinny vertical slice corresponding to winning by 6 at home in the first game. And it looks like it's sort of equally likely to win or lose in the next game, which is surprising. Maybe not so surprising. It's only 6 points. But it tells you some information. The question is, what do I do with this big blob of points? How do I put it all together? And for this, I use logistic regression and I fit a model to this data. And it looks like this. And the green dot, which is kind of small on the screen, corresponds to winning by 6. And it's actually predicts the probability. So the y-axis here is actually the probability of winning on the road in that next game. And you can see it's just under a 50% probability, which probably is not what I would have guessed if you asked me. And what's surprising, if you win by 20 at home, you can see that it's definitely not a guaranteed win in the next game. It's very far from that, which to me was very surprising until I looked at the data. So this also gives me a tool. I can adjust for neutral games as well. And this helps me score how much each victory or each game is worth. Now, one of the challenges with this model is if you look at a point here, any point here, let's take the 0, margin of victory of 0, and you win by a point versus you lose by a point. That difference is pretty important because in one case you won the game and the other you lose the game. But you'd still get the same amount of credit in terms of your win probability in the next game. And I want to adjust for that and give a little bit more credit for actually winning the game. Okay, so I start with this model that's the output of a logistic regression model. And I should say logistic regression is a real workhorse in data science and prediction, and it's widely used. So this is an excellent tool. I also look at this green line, which is just pure wins and losses and ignoring home court advantage and strength of victory. And I blend them together to get something that looks like this red line. So there's a big jump up when you win by at least 1 point, and then you get more and more credit for each additional point that you win by. When I do this, it becomes a rough tool for assigning credit for a game, and then there's 30-something games that each team plays. Okay, so this brings us back to our example. So this is helpful for determining the probability or the weights on 4 arcs and what will eventually be a huge matrix that is 358 by 358 because there are 358 teams. And in this case, there's a win probability of 48% next time when Wisconsin plays Minnesota on the road in Minnesota. But I blend this with the fact that Wisconsin actually won the game, and I give them a weight of 0.55 for this game. And, I'm sorry, 0.55 is the win probability on a neutral site. And, but then Wisconsin gets 0.67 effective wins when I blend that 0.55 with the fact that they actually won the game. And if you're curious, if they did win the next game, they did, but just by a point. All right, so the data wasn't so far off in this case, showing that that was kind of a toss-up in the next game. Okay, so then I have to repeat this. There's thousands and thousands of games, so I use a computer to do this, and I'm just demonstrating it with cats because this is a lot more a fun way to demonstrate how I filled out my matrix than with showing you the code. And then I put it all together, and then I solve a series of linear equations using linear algebra, and we get a rating that for each team that can be ranked. Okay, so I'll give you a spoiler. This isn't all the games in the season because I can't fit 358 teams on a slide that you can read. I just took the conference games from the Big Ten and ranked them. And I'll go through a slightly extended example of this in a second. What's really interesting is that Illinois and Wisconsin tied for first in the Big Ten, but Wisconsin finished third. So it maybe had to do with their strength of schedule, but I think it more has to do with the fact that Wisconsin won a lot of really close games. And unfortunately for Minnesota, but they ended up finishing last. All right, so at this point, you might be wondering, what are the other ways I can rank a team? That seems like a lot of work to fill out a large matrix. And there's a lot of matrix math and linear algebra and ranking. There's several classes of models that are widely used. I'll mention a few here. They all follow the same basic approach where you're taking some data, you use a model to make sense of it, and then you produce some ratings or rankings at the end. One is pure win-loss methods that typically ignore home court advantage in the score. You can use Markov chains here, a simpler version of what I had, Collie matrices, logistic regression, and RPI is actually, which I don't like, is like a win-loss method. Scoring methods build on that and actually look at the scores, or at least the points scored versus allowed. You can again use Markov chains, Poisson regression, Pythagorean scoring, which is a very classic sabermetrics method that came out of baseball analytics back in the day, and Massey ratings. And then there's a bunch that aren't included on this slide. And of course, you can use the gut feeling methods. This is expert opinion, coaches polls, press polls. So you've got some options. And I will say that once you start ranking teams, you'll start to want to explore some of these options, which I have definitely have done. So over the years, I've started producing more rankings, some of which I've came up with, some of which I've borrowed from others. And the rankings don't always agree, which leads to a conundrum. How do I rank the teams if there's disagreement? So what I've asked is, how do I combine these into like an Uber ranking? And I do produce composite rankings. And there's a lot of election methods, which are not, election methods for democracy, but election methods for making sense of math models that disagree. And there's actually a very wide academic literature on this. And I do combine some rankings now. All right, so I want to come back to the Big Ten. This is the men's regular season here. I just looked at their conference games. They each played 20 conference games. And this is their rankings. And there were some ties. So you might notice that there's 2 first place teams. There's a few other ties on this list. This is just their sheer ranking according to their win-loss record. So it doesn't look at strength of schedule. So they don't play every team twice. They play about half the teams twice. It doesn't take home court advantage into account. It doesn't look at point differentials or score differentials. Okay, so let's look at how the win-loss record compares to different rankings that I can use. Okay, so here are 5 different rankings. So 2 are mine, 3 are not mine that I use. And one thing you'll notice is that there's general disagreement, but not total disagreement. There's one thing that they agree on, and that is that Indiana is a totally mediocre team this year. And surprisingly, Wisconsin, which was tied for first, does not appear first in any of the rankings I've looked at. In fact, it's 6th in one of them. And this is pretty informative. And this is basically the procedure that I use every week when I rank sports teams, because I look at all of the games. And if I put this all together, what I do is I wrap a Markov chain around my rankings, which is like wrapping a Markov chain around another Markov chain, which I'm again demonstrating with cats. And the basic idea here is we randomly choose a ranking, randomly choose a team, and then randomly move to a team that is ranked higher than or equal to the current team. So I don't have to worry about, do the scores actually make sense when I look at one ranking versus another. And when I do that, I get this composite ranking. That's this column here in red. And you can compare it to the rank just according to record or any of the individual rankings. And this is where I get that Wisconsin is ranked third in this ranking. And in my composite ranking, Nebraska is ranked last. Right, so if you want to know how I did, these are my Selection Sunday rankings. Gonzaga appeared a little low in my composite rankings, but other than that, I found them pretty close to how the teams were actually seeded. So Arizona is my overall #1. They're a #1 seed, as are Kansas, and I believe Baylor. I'm trying to remember the bracket exactly. Unfortunately, I have Wisconsin 18th after being 13th most of the season, but they had a couple losses the last 2 games. And these are my Selection Sunday rankings from last year. So it doesn't include the tournament games. Baylor was #1 after the tournament, but they were ranked #3 right going into the tournament. Wisconsin was 23. All right, so one of the topics today is like actually trying to predict what will happen in the bracket. So instead of talking about what will happen in a basketball bracket, I'm going to talk about college football briefly and some of the insights this has for filling out the bracket. I do some rankings on the college football for the college football playoff, and I've just described how I do that. So I'll talk specifically about how I forecast the rest of the season. And what's really fascinating about college football season is that they have these college championship games at the end of the season. And so it's like you might have this game in your schedule, you might not, depends on how well you did during the season. And using that information, I can simulate the rest of the season, including the conference championship game, and then rank the teams to figure out who might be ranked in the top 4. And one of the observations I've had over the years is that remaining schedule is really crucial. It's a short season, every game counts, and strength of schedule and who those opponents could be is important for determining what can happen next. And I've generally agreed with the committee every year, except for the 1 year that I'll highlight today. There was just a minor disagreement, and I don't know, maybe I would have made the same choice. But I'm going to highlight the 2017 college football playoff, which I know is a while ago. This was a sad game or sad season if you're a Wisconsin fan, because they lost in the Big Ten championship game to Ohio State. And Alabama, which was not in the SEC championship game, and the first team at that point to not have won a college their conference championship game to make it into the playoff. All right, so here are the rankings, or here's the official selection committee's rankings on, I guess, the selection day. But every week of the season, I rank the teams. And so this is like the second half of the season up through the selection day at the rightmost column. And I highlighted Wisconsin in red, which you can see was very briefly ranked #1. And that was right before the Big Ten Conference Championship game, after which they fell to 4th. What's interesting is that if you look at that top row, it's like Alabama, Georgia, Georgia, Alabama, Alabama. So you can see that the SEC teams are ranked #1. The boldface teams are the teams in the college football playoff. And you can see that they're not ranked in the top 4 the whole season. They're generally in the top 10, and each win can bring a team closer to the playoff. Okay, so take a look at that top row. These are the rankings, and they tell you who's the top ranked team now, or then, I guess, who's the top ranked team at the end. They don't tell you anything about who will be the top ranked team at the end of the season. And that's what my forecasts do. So I simulate thousands. Before I do that, I'll show you Alabama. So Alabama is the team to watch here. So they were ranked #1. They lose to Georgia. And they also lose the chance to go to the SEC Conference Championship game. But they only fell from 1st place to 3rd place. They lost to a very good team, one of the best teams in the country. So it didn't affect their ranking a whole lot. And I'll come back to that momentarily. This was also the Central Florida year, the undefeated Central Florida team. And you can see they never cracked my top 4. And this is in part because strength of schedule is really crucial for making it into the college football playoff and being one of the top 4 teams. You need to win a lot of games and you need to have a really good schedule. And then we've got Wisconsin. They were ranked 4th even after that loss. And I can see why that loss meant that they didn't make it into the college football playoff. All right, so this is a different chart. This is showing the forecasts from these points in time, these dates in time, of who would be the likeliest teams to make it into the playoff if we simulate the rest of the season. The column on the right, there's no games left, so there's no simulations at that point. That's just a static ranking. But if you look at that top row, you'll see Wisconsin appears multiple times, and they're pretty high in this chart. Also, Clemson is a little bit higher in this chart than they were in the rankings. And this is because the Big Ten West is not really the hardest path to the playoff. It's a very easy path because Wisconsin doesn't always have the toughest opponents compared to maybe the SEC or the Big Ten East. And likewise for Clemson, the ACC is, they're good teams in the ACC, but they're very beatable teams for a very good team like Clemson. And so this is where the path to the playoff is slightly different for different teams. What's interesting here is Alabama. I showed you in the last chart, they fell in the ranking from 1st to 3rd when they lost a game. But in terms of that path to the playoff, they fell from the 2nd most likely team to make it into the playoff to the 9th most likely team. And this is because when they lost that ability to play in the conference championship game, that really meant they were very unlikely to make it into the playoff. But luckily, other teams lost and they were able to get a bid into the playoff. We're lucky for them. Central Florida only appears to have any possibility to making it into the playoff right at the end, even though they were ranked in the top 10 for most of the season. And Ohio State didn't make the playoff, so some of us can at least celebrate that. This is the rankings that I have versus the college football playoff selection committee this past year. So again, we agreed on the 4 teams. We just swapped 2 of the teams in the rankings. But I think it's just so cool that I can produce rankings that look pretty similar using Markov chains. At this point, I want to just point out 3 takeaways. One is you don't need a lot of data to create really good rankings. The key is to have a good model and to have some good basis for coming up with those rankings. I'm asked a lot about big data, and most of what goes into sports analytics is not big data. It's a really clever model with some small data. The second thing is I've been producing rankings year after year, and I always, except for that one exception, I've always had the same top 4 teams as the college football selection committee. And that is a committee of experts. And I think, I don't understand football at that level that they do. And I think it's just absolutely beautiful and cool that the rankings can produce the same, rankings using analytics can produce the same rankings of those by an expert. Blows me away every year. I never get tired of it. And the third is, there are not a lot of other women in sports analytics. So if you know any, ask them to join me. Or if you are interested, please definitely join me. I do contribute my rankings for both football and basketball to a site that collects them, run by Ken Massey. And he said he collects over 100 of these rankings, and I've been the only woman contributing for a while. And I'm also the most correlated with consensus. So I'm sort of proud of this, but I'm also pretty sad by this. All right, so now I want to make some data-driven tips for maybe winning your office bracket pool or pool that you're in. Obviously, the first step is really to check the rankings. At this point, you might be interested in my rankings or other rankings that are out there. Mine are based on the logistic regression Markov chain model that was developed from Georgia Tech. There's also Five ThirtyEight, Ken Pomeroy, Sagarin ratings, ESPN has ratings, And I contribute to the rankings clearinghouse at masseyratings.com. These are all good places to check to look at the individual matchups that might occur in the bracket. Before I give you some tips, I'm also going to remind you that it's really hard to pick a good bracket. Nobody's ever picked a perfect bracket. It's hard to get the 4 teams right in the final 4. Millions and millions of brackets are filled out each year, and some years as few as 2 teams get all 4 of those final 4 picks correct every year. So it is really hard. What's also worth pointing out is that some years are harder than others. So you can see here, yes, one year there were only 2 brackets that had all final 4 teams correctly picked. But on the other extreme, 182,709 were correctly picked in a different year. It all depends on what happens that year. Some years are harder than others. But they're probably going to be just as hard for everybody else in your pool. I have 3 main tips. The first is don't join the big pools. So if you have 10 people in your pool, you have like a priori a 1 in 10 chance of winning the pool if you just fill out a bracket. If you use analytics and fill out like a good bracket, maybe you double that, and now you've gone to 20%, which is a pretty big increase. If there's 1,000 people in your bracket, you have a 0.1% chance of winning. And if you double that, you still are probably not going to win your bracket. So the analytics makes more of a difference in a smaller pool. The second tip I've had is going to sort of contradict what I've learned from rankings, which is looking at like specific matchups and the specific quality of the teams. But I will say, don't totally ignore the seeds. Much like the college football playoff, they tell you about a team's path to the Final Four and beyond. So I'll give you a couple of pieces of data points here. One is that all 4 1 seeds only once made the Final Four. So that's like a clue to filling out your bracket. Usually there's 1 or 2 1 seeds in the Final Four. And it's true that some seeds generate more upsets than others in the first round. But we're looking at like the whole bracket as a whole and how deep teams can go into the bracket. And the first round upsets usually aren't, totally predictive in how your bracket's going to do. One thing that's interesting is the 6 and 11 seeds typically, well, they do go the longest before facing a 1 or a 2 seed. And this is a hypothesis for why 6 and 11 seeds have the potential to go further into, deeper into the bracket. I'll show you some data. These are low seeds, I think seed 6 and greater, that have made it to the Final Four. And I think I counted like 15 total times this has occurred. And only 5 times did an 11 to 16 seed appear in the Final Four. That's out of 36 tournaments. But if you look at these numbers, you see a lot of 6 and 11 seeds, and you see a couple of 7 seeds. So even though there's a lot of like 7-10 upsets, the 7 seeds tend not to go very deep into the tournament, nor do the 8 seeds as much as you'd think, although there are some 8 seeds on here. The third tip I have is that, there are 68 teams in the tournament, but they all don't really have a chance to win it all, or even to make it into the Final Four. And I do remember all the seeds that are really low that make it into the Final Four. But a few years ago, I did some of the calculations, and I used the Five ThirtyEight tool that had like win probabilities for the tournament. And these are overall win probabilities. And there were 4 teams listed here that are the 1 seeds, the top 4 seeds in the tournament. And if you looked at their overall chance of winning the bracket and you added them all up, it exactly equaled 50%. So you have a 50% chance, roughly, in any given year, that one of the top 4 teams will win it all. And the other 64 teams share the rest of that 50%, the other 50%. So I usually try to have fairly good teams in my Final Four and winning it all, not always a 1 seed. But that there's so many points that are allotted to those games in the Final Four and the national championship game that I usually have a bit of a top-down approach. Everybody does it a little bit differently. I looked at the tool today, and the top 4 teams have a 53% chance of one of them being the eventual winner. And that's kind of a good rule of thumb. All right, so with that, I'm going to start answering some of your questions, but I want to remind you that engineers also care about bracketology. And in both bracketology and engineering, we're trying to leverage data to make better predictions and make better decisions. And it's something that we have in common. And that's why me as an engineer is really interested in sports analytics. So thank you for your attention today. And if you have questions, specific questions about your bracket or filling out a bracket in general, I'm happy to take those questions. Thank you. All right, and you can ask questions by chat, or you can unmic yourself. Oh, thank you, Darcy.
I got a question.
Okay.
So when you're filling out your bracket, how do you keep the personal factor out of it? You know, like specifically the Wisconsin games. How do you keep that emotional tie down, or do you ever go against the data and say, you know, I just have a good feeling about the team this year or something? Do you ever play those factors in?
Yeah, I do a little bit. It is really hard. I sometimes fill out the bracket that I hope happens and then have like a different bracket, but it is really hard not to either have the loser insurance and go against my team or put my team in the Final Four. I will tell you, one of my years I picked North Carolina as my overall winner, and I spent the whole tournament rooting for North Carolina, and I kind of hated myself a little bit. No offense to North Carolina. So I do try to go by the numbers, but if there's 2 teams, and there's always like 2 teams at some point that I think are kind of a toss up, I kind of put the personal in there a little bit. And that's just my style, because I want to have fun watching the tournament as well. That's also a goal, is not just to win my tournament, but I want to actually, you know, have fun rooting for the teams I want to root for. And finding the right balance, I think, is a personal decision with that. So I don't know that I'm going to have so much fun cheering for my bracket that I filled out. I might make some changes later on tonight. And the other strategy for that is to fill out multiple brackets for those different realities. Some of them can be personal and some of them can have less personal pieces.
Hi, Laura, it's Martin. I'll ask a question if that's right. I wonder how portable this is to other sport forms. For me, specifically rugby and Australian rules football, I wonder if I'm sure you've got this question a fair bit. The methods seem very clear and straightforward. Frankly, I've never tried it in any sport. And I just wondered if you got any tips for someone wanting to apply this like immediately to the Aussie rules football.
Yes, you could totally apply these methods to other sports. One of the tricks is the conferences and college sports is particularly challenging. So if it can handle that, it can be portable elsewhere. I do have a trick with like the non-Division 1 games. It's very unique that they play teams outside of the league, essentially. And then I have a couple ways that I correct for that. And then a lot of methods ignore those as well. I can't use some methods like the ELO ratings that are used for chess and some other sports. I tinkered with those a little bit, and I just could not get them to work in the sports method for college sports with the very unequal conferences. So I would say, yes, you've got a lot of options potentially.
Thank you.
I have a question about like home court advantage. Obviously, in the tournament, it's not as much of a factor because most of the games, like besides a few, are like not in like a home city or stuff. Like, how do you factor in like a team that like has played like really good at home throughout the year in terms of like, because they're going to be playing neutral site games in the tournament?
That's such a good question. I've been meaning to study that a little bit more. One thing is that it's tricky because the way that they schedule and seed the teams, they are supposed to give home court advantage to I think the top 3 seeds or so. And then they might specifically move other teams around the country, even if there's like a nearby location, so that other teams don't get home court advantage. And it's a little bit baked into the system that it's not like during the season where you're like half of it's not really a neutral court, so to speak. So Wisconsin has a 3 seed and it gets to go to Milwaukee. And they tried to do that for the top seeded teams. And they make sure that if they're playing a lower seeded team, that lower seeded team doesn't have a home court advantage. So it's a little bit tricky to look at that in terms of the bracket. And I don't know that the data says about the teams that have to like travel across the country in 3 time zones and the week where we've all lost an hour of sleep. I don't know how much that affects some of the teams. So it's a little less straightforward in the bracket than it is in other sports where they know that there's a big effect for teams that have to travel a long way and they're usually playing at someone's home court. So I'm sorry, I don't have a better answer for that.
Oh, that's all good. Thank you.
Hello, Professor Albert. Good to see you again.
Nice to see you too.
I was excited when I saw this come up. So thank you again. But one question I had and have actually been thinking about quite a bit lately is sort of related to like recency and momentum. So have you done any like research and digging into like, is momentum a thing? I think first of all, but then also things that are maybe more obvious, like injuries that may occur on various teams that kind of take players out. I think 538 does some models where they look at like player-based like matchups and things like that. Have you done any of that and found any like validity to it?
That's a good question. I've wanted to do that. I've been trying to find a student to take that on to look more at the predictions in the tournament. So the rankings admittedly ignore a lot of that. And in some sense, they should, because you should get credit for your wins and losses. And that tells you some information, but then it's missing that predictive piece about injuries or whatnot. And so I don't have a good answer to that. But I do personally, I look up injuries and I do look to see if teams had lost several recent games or won several recent games. Not that I really necessarily believe in momentum, but maybe it's telling me something a little bit about some of those recent questions. Because the team at the beginning of the season isn't that same as the team at the end of the season, and that goes beyond injuries. And I don't attempt to address that question, but I am curious myself.
That's fair. Yeah, it's definitely a bit of a tricky one, but cool. Thank you.
You're welcome. Nobody's asked me about Wisconsin yet, so I will just toss that out there and then we can wrap things up. But I do think Wisconsin did get a good seed at number 3. They have home court advantage essentially, and I think they have a pretty easy path to the Elite 8. But there's no guarantee. It's going to be 3 tough games, maybe like 2.5 tough games, but they could have done a lot worse.
Do you factor in like certain portions of the bracket that seem weaker than others in terms of like a team's path to like the Elite 8 or Final 4?
Absolutely. So this is where I look at the individual rankings, and mine disagree. I don't just look at mine though. I look at some others, experts, and I try to assess which one I think might be harder. And I'm a little bit more careful in those areas of the bracket. So the way the committee sets it up is that they come up with a ranking of these teams 1 through 68. And then the seeds themselves are sort of fungible. They might say like Wisconsin should have been a 4 seed, but we're going to move them into a 3 seed because the Big Ten teams can't play each other in the first couple rounds. And they have this home court advantage thing they're trying to do for the top teams. And so a team seed that they should get can go up or down by 1. And then they also try to rank the 1 to 68 to balance the strength in the 4 quadrants, but like it's never balanced. There's always the one quadrant or the one region that's always harder than the other ones. And sometimes that can be like highlighted if you look at different rankings. You're like, wow, that's even harder than they thought it was going to be. So that's something that I look at. And quite often the best team coming out of each region isn't a 1 seed. And that's usually informative. And sometimes you see that like a 1 or a 2 seed has like an incredibly tough path personally, like for that team to get to the end. And I usually don't put them in my final 4 because I just see too much risk. And that's the path to getting to the final 4. If it's just too hard, I usually bet against them. But I've never filled out a perfect bracket. So like everyone else on the planet, but I try to, I try a few things. All right. Well, thank you so much for coming today. It was nice to see some familiar faces in the audience, and definitely stay in touch and tell me how you did in your bracket. Over the years, sometimes I do get good news from people, and that's always exciting. Yes, have a wonderful day. Thank you.
Thanks, Laura. Take care.